2025 didn't go as planned.
535 मार्क्स, बस थोड़े से मार्क्स से रह गई। बायोलॉजी ठीक था, केमिस्ट्री भी, पर फिजिक्स वो फिसल गया। इस बार पढ़ाई नहीं, तैयारी करो, वो भी स्मार्ट तरीके से, क्योंकि इन्फिनिटी लर्न लाए हैं अट्रेया, इंडियाज मोस्ट पावरफुल नीट रिपीटर्स प्रोग्राम विद P² CB, जिससे फिजिक्स पे होगा डबल फोकस।
Don't just make it your last try, make it your best one yet. Join Infinity Learn today.
Hello, good noon, my dear students. Welcome to one more amazing session from Infinity Learn. This is Suresh, Faculty of Chemistry for you. Today we are going to discuss about the most important topic is thermodynamics. Those students preparing for NEET examination, so anything comes as if like a physics or any mathematical approaches, so it is going to be the toughest topic. So from now onwards, you say this is the easiest topic to you all. So I can assure you at the end of the session, I will bring the difficulty level of this thermodynamics into the normal level, so you can plug and play and you can do the best. Ready for that? Please confirm you are all able to hear me, can see me. My dear children, just say hi and give a fire emoji, thumbs up in the chat box so that we can start the class. How are you all, my dear students? So what do you think about thermodynamics? Actually, this is the thermodynamics is grade 11 topic my dear students. So this session especially is effectively useful for those students preparing for your grade 11 and grade 12 and the droppers as well. Yeah, by the way, coming to the droppers, so we have a special amazing things for the droppers. Ready for that? So Infinity Learn by Sri Chaitanya Academy, we are offering Atreya program. So this is your Atreya program. So I want to say, if you do it well in the NEET 2025, all the best and congratulations. And if something happened and you are not able to just reach your goal at your extent, however, you deserve to get a NEET seat. And this Atreya program is bringing to you from a state of I didn't do to I will do it. Yes, this is a revolutionary program by Sri Chaitanya Academy by Infinity Learn, and this is Atreya program. We are launching P² CB program. As you know, physics is a nightmare for the entire students preparing for NEET examination. Now from now onwards, the physics is on us. We are preparing the program in such a way that whatever the level of the student may be, physics is going to be the super awesome and easy for you guys. And hi Deepanshu, Radhe Radhe, good evening, good afternoon I say, how are you? And thanks for attending our classes on a regular basis. And when it comes to the regular basis attendance in the 2025 we witnessed and 2025 also, those who attended the YouTube classes with us in Infinity Learn, they secured very good and comfortable score in NEET examination, and they are about to enter into the NEET and medical colleges. And 2024 here and 2025 also it is proved. So I really recommend my students, please attend our class regular basis and please like our session, and you just share these sessions with your friends and इन लोगों को भी फ़ायदा होना चाहिए. And please subscribe to NEET Infinity Learn channel so that whatever the sessions are going to be given update to you all guys. Okay, and moving ahead my dear students, so this Atreya program, India's most powerful revolutionary NEET repeaters program, which is P² CB, and the link is available in the chat box. You can just click it and just proceed it, and a short promotion only. After that I am directly getting into the concept. You please stay online and let us discuss about what greatness of this. So this is a revolutionary program where you have double focus on physics with chemistry along with biology. So once you did well, yes, chemistry अच्छा था, biology अच्छा था, लेकिन physics थोड़ा सा गड़बड़ चलता, so that the physics is going to be made so easy. So the program details हैं, and this batch is commenced May 23. don't worry, if you enroll in this course, you will be allocated a fresh batch, and days of the week, it is from Monday to Saturday. It is a 6 days and Sunday ko chutti hai. You can go for an examination and assessment kind of thing. And also 3 classes per day. उसमें 2 concept class होगा, एक practice class होगा. So hi Nandini, good afternoon Nandini. And you see, the program is designed in such a way that student को इतना pressure नहीं देखता, लेकिन result आने के ज़्यादा संभावना भी मिलता. And you can see 18 classes per week, उसमें double practice class for physics. Practice class में क्या होगा? A group of students will be there and solving questions along with the senior faculty. And you will be having a good rapport with your senior faculty. So, my dear students, Aman Jaiswal, hi, how are you? So, how are you preparing, Aman? Okay, so the course features which contains 465 classes by expert faculties, and the DPP is 240, and 240 DPPs will be given to you. So that if you do 240 DPPs from the all subjects, definitely all the questions you can see in the NEET examination matches with this for 240 DPPs. You can see dedicated practice sessions, 120 practice sessions will be there with your senior faculty. And this is very important. When you sit in the practice batch consists about nearly 20 students, and you will not be as one in hundreds of students. And this is so valuable. If the student, the batch strength is very less, you will be having a very good rapport with your faculty, and you can have a customized discussion with your faculty, and you can directly talk, and you can have whatever the doubts you are having and the problem solving strategies in a side by side way. And this is very important. Total 11th and 12th syllabus NEET examination का हिसाब से cover किया जाएगा. And this is very important, my dear students. Link is available, and just click it and you can enjoy it. And those who did in NEET examination, congratulations, and you can just in the description box link is available, and click it and you can find your dream medical college. And we are Infinity Learn, we teach and we train and will make you to write NEET examination. After writing NEET examination, getting a medical seat is also a game. So we will make you to play in the game, and we will support you till your journey till medical college. Ready for that? Okay, so the link is available and you can just add it and you can get the details about this. So promotion is over. And dear students, let us talk about what you learn in the thermodynamics. So thermodynamics is a collection of all the concepts that are there in NCERT ka hisab se. So everybody take a pen and paper and write all the concepts, key noteworthy points and formulas and the tricks. So हमारा ये जो क्लास में आपको ट्रिप्स भी दिया जाएगा. Okay, so everybody who are online, please like the button so that we can start. You're going to learn first law of thermodynamics and entropy, and second law of thermodynamics, Gibbs free energy, and also spontaneity and thermochemical equations, and Hess law of constant heat of summation, and thermochemical calculations. So आज हमारा जो क्लास में I want to take these 1, 2, 3 points, and we will be having 2 more sessions for this. So it is not a one short session, and it is going to be a lengthy session, and I want to ensure this you will be very good at first law of thermodynamics, entropy, and second law of thermodynamics. So ready for that everybody? Now stay tuned. Aman Jaiswal, Nandini, Dipanshu Yadav, you please continuously discuss with us and use the chat box generously, and you can have a very good interactive live session, and this is not a radio session. My dear students, to have this kind of sessions from the expert faculties, you need to go to a coaching center and have to pay huge amount of money, but in this class everything is simple, free. So you just take an advantage of this. Okay, who is that CR and आपका नाम क्या बेटा? And let us see before going for the first law of thermodynamics, let us go in details about these fundamentals and take a note and I will give you some important short tricks and tips. And let us talk about thermodynamics. So, a system and surrounding and universe. A system and surroundings a universe. You take a cup of coffee. So, you take a cup of coffee, hot cup of coffee. Okay, so it is a hotter body. So, it is so hot, घर में है, and it is going to be the system and it is going to be the surroundings. So, what happens, you just see the logic of the thermodynamics isme. Heat of the hot coffee is more and the surrounding is said to be a colder system. So, that heat is going to be transferred from the hotter system to colder system. So, why not from the colder system to hotter system? So, how much heat is transferred? Why it is transferred? Everything is studied by using thermodynamics. Actually, a physical chemistry. बच्चों, a physical chemistry में क्या होगा? जहाँ पर एक क्वेश्चन में न्यूमेरिकल आता है, फिजिकल केमिस्ट्री बोलना है क्या? नहीं है. Okay, that is not at all actually the way of defining physical chemistry. So, chemistry is all about a study of chemical reactions. Agree? And in that chemical reaction, reactant is converting into the product. And thermodynamics is going to decide whether the reaction takes place or not. That is decided by the criteria of spontaneity. We will eventually end up that situation, right? And this is called thermodynamics, to say that various levels of thermodynamic systems are there, various levels of thermodynamic properties, thermodynamics laws are there. For that, 0th law, 1st law, 2nd law and 3rd law are there. Okay. And once the chemical reaction is started, given permission by thermodynamics, you have to talk about how much reactant is converted to the product and how much a product is converting back to the reactant. That is the state of equilibrium we have to study. So, the state of equilibrium is studied here. So, equilibrium is another physical aspect of this physical chemistry and chemical reactions. And also, once the reaction is started, how fast the reaction is proceeding and the speed of the chemical reaction is studied by using chemical kinetics. So, various factors that influence the speed of reaction is studied in chemical kinetics. So, there are 3 core topics that we have: thermodynamics, equilibrium and chemical kinetics are the actual core part of the physical chemistry. Then what about electrochemistry and all? These are the application derivatives. Okay, anyways, so what is a system? Okay, Aman Jaiswal, okay, Deepanshu Yadav and Nandini, who are there in the live session, you please just tell me what is a system. A system is a part of universe which is under thermodynamic study. This is a system and it is, we are studying in this place how much it is going on, how much heat is coming up. So, this is what is called as a system, and anything about this system is called as surroundings, and system plus surroundings is called universe. You do not say that universe is something about cosmic zone. Okay. Anyways, the system and surroundings is separated by a real or imaginary interface. Real or imaginary interface, that is what is called as a boundary. That is what is called as a boundary. You know what is a boundary is of 2 types, diathermic and adiabatic. And diathermic means the boundary which allows the heat to exchange, and whereas an adiabatic is a thermal insulator boundary which do not allow the heat change. So, dear students, hope you are understanding. Just place any doubt that you have in the chat box, and after strongly I recommend, my dear students, take a pen and paper and write the noteworthy points. That is the number 1. Attend the classes on a regular basis. So, please subscribe to this channel so that you will be getting update about when the sessions are going to happen. So, as you are a student, you may be able to attend the class, you may not be able to attend the class online. So, I strongly recommend to attend the class online. If you are not able to attend the class online, you please watch the recording, so that even in the recording, if you have a doubt, just mention in the comment box, so that every day I am going to read these comments and I can give you the answer there itself. है ना? Aman Jaishwal, Nandini and Deepanshu and CR, just give a thumbs up and fire emoji. आगे बढ़ता हूँ मैं. Yes. So everybody, come on. So let us talk about the systems now, and then let us talk about thermodynamic properties, and let us eventually go into the first law of thermodynamics. That is what I wanted to say right now. So here there are three major systems we study in thermodynamics. One is a open system, and it is a closed system, and an isolated system. So then what is an open system? Open system is a system where you can exchange the mass and matter, and you can exchange the heat. You can take an open cup of coffee. This is an example of an open system. And you can see the closed system, it is closed. So matter cannot be exchanged, rather you can exchange the heat. So energy transformation can happen. So my dear students, this is a container aluminum bottle, and it is a closed system. You can't take the water and you can't put the water, and you can just keep it in the refrigerator, and this can exchange the heat. So it is a closed system that we have with our. So a closed system, it is an aluminum bottle and it is a closed system. If it is a thermo flask, you can't exchange the matter, you can't exchange the heat. That is what you can say. It is an isolated system. ये isolated system में क्या हो? Neither mass nor energy is exchanged with the system. Are you getting or not? My dear students, here open system, closed system and isolated system. Open system, you can exchange the matter as well as heat, and closed system, you can't exchange the matter, rather you can exchange the heat. And an isolated system, you cannot exchange the heat and you cannot exchange the matter. So dear children, let us go more details about this. So here you have two types of functions, thermodynamic functions, a state function and a path function. So thermodynamic properties, the state function and the path function. What is this function or a property? And when a system changed from a state to another state, this is called initial state and this is called final state. So there are certain measurable properties are called properties are called functions. So these measurable properties which depend on only on initial state and the final state, and this is called state function, and it is independent on how the state initially is changed to the final state. That is called a state function. State functions are the property of a system that depend only on its current state and independent on the path, how it is. I want to say water, it is a liquid and it is converted into ice, it is a solid. How liquid is converted into the solid and how it is done we don't know. And if it is ice, is converting into a liquid. It can be converted into liquid, ice can be converted into liquid by simply put it in the hot bath, or you can simply hammer it, or you can just leave it at the room temperature, it can do it. And that is called path, it is independent. So path functions are different. Path function depends on both initial state and the final state as well as the path in which it is changed. That is what is called as a path function. मेरे पास कुछ टेक्निक है. सो ये स्टेट फंक्शन बोलने के लिए एंड पाथ फंक्शन बोलने के लिए सिर्फ आपका हीट that is indicated with a Q and work that is ये path function. That's it. सिर्फ दो path functions है. Apart from that, all functions are state function. Pressure, volume, temperature, number of moles, anything is depend upon the state. And one more important thing, if one state function is changed, automatically all the state functions are going to be changed, right? And state functions are indicated by a capital letter and a path function is indicated by a small letter. है ना? My dear children, Aman Jashwal, Nandini, Dipanshu, and my dear CR, and you just give a thumbs up and fire emoji by chat box so that we can just move ahead. Those who are online, you please like the session so that we can rise with a lot of confidence. And these are the sessions which are very valuable. My dear students, please take a note of the noteworthy points, okay, and rise with the josh, and the josh should not be calm down, hai na? Come on. After completion of the state function and path function, I just want to say intensive properties and extensive properties. This is another version. What are intensive properties? Intensive properties and extensive properties. Intensive properties are the physical properties that do not depend on the amount of the matter. Do not depend. They are intensive properties. And extensive properties that depend on the how much matter is there. So, depend, you can say volume. You take this much volume, the value is dependent on how much you take. You take 10 grams of water, 100 grams of water, 1000 grams of water, 10 ml, 100 ml, 1000 ml. So, volume value is also increased. So, a gas, 1 gram of hydrogen, 2 gram of hydrogen, 10 gram of hydrogen, volume is increasing as the mass is increased. And talking about the density, just example, I just want to say density. You take a pure water, density is 1. Okay, beaker of pure water, what is the density? 1. And you take a tumbler of water, pure water, density is 1. You take a tank of pure water, its density is also 1. So, density is a parameter. It do not depend on how much matter you have taken. So, this is about the extensive property and this is about the intensive property. So, I already promised you one thing. During a class, I want to give you a trick. So, I want to say the ratio of two extensive property. So, extensive property upon extensive property is going to be intensive property. This is a trick. This is a trick. One extensive property. So, I want to say weight, mass is an extensive property. है ना? Mass is an extensive property. Upon volume is an extensive property. Is going to be density. So, extensive ratio of the extensive property are going to be. So, it is an extensive property and it is an extensive property and it is going to be intensive property. Okay. Extensive property values you can add. Intensive properties you can't add. So, they are called additive functions. These are additive functions and these are not additive functions. You all like this? Dear children, you all like this? So, let us make 2-3 sessions for the thermodynamics, not a matter. Actually, I will tell you, those who are preparing for NEET examination, if is asked, what is your favorite subject? They simply biology. What subject you feel it is difficult? They simply say physics. And what about chemistry? You say mixed answers. If I enter into the chemistry, if I ask you, what is your favorite topic? You say organic. You say something or the other, hybridization, chemical bonding kind of thing. What is the difficult and fearful topic in the chemistry? What is your difficult and fearful topic in the chemistry? Mention in the chat box. Simply you say any topic from the physical chemistry like thermodynamics, like electrochemistry, like chemical kinetics kind of things. So, no worries, my dear children, we are working hard for thinking and doing a lot of research. So, how to give the best for the students and how to make the students so easy for any difficult topic. You feel it is FF at option, you can say it is an equilibrium. ये भी अच्छा बात है. Okay, no worries, equilibrium we have a class and we will be extending the things. Okay, so please like the button right now. Please like the button right now. Take a snapshot of this. Now I want to give you the list of the intensive properties and extensive properties. You say Sahid, you say chemical kinetics. Okay, do you feel thermodynamics is easy? If you say chemical kinetics is difficult, probably thermodynamics is also a difficult topic. Yeah, हाई जोश में है. ओके, थैंक यू. एक बार लाइक बटन दबाओ. अब जब आप लाइक बटन डाल लें तो लाइक का नंबर मेरे सामने इंक्रीज किया जाएगा, आपका जोश बढ़ जाता. ओके, नाउ लेट अस सी द you can see here intensive properties list and extensive properties list. So what it is an extensive property? Depend. Intensive property do not depend. So it depend. And it is going to be do not depend. Now we can see the extensive properties: energy, entropy, gives energy, length, mass, particle number, number of moles, volume, electric charge and weight. These are all the dependent, right? And independent: chemical potential, concentration, density, ductility, elasticity, hardness, melting point, boiling point, pressure, specific energy, specific heat capacity, specific volume, and spectral absorption maxima, and temperature and viscosity. And उसमें एक चीज बताना चाहता हूँ, फिर भी एक, what is that? If you measure any extensive property per mole, it become intensive property. I'll write it here. If I'll write it by using a good color so that it can be visualized. If extensive property is measured, expressed in terms of per mole, it will become intensive property. So what is this? Simple trick, simple trick. Use these simple tricks. Why not temperature? Okay, temperature is a state function here. Now you can see entropy or enthalpy. Entropy is going to be extensive property. Yes, it is given. If molar entropy, is going to be intensive property. Arey beta, you say that. Thank you, real sense. Thank you very much. And why not temperature? Temperature is not a quantity, temperature is a scale. Heat is a quantity. We are talking about the quantities. समझ में आ रहा है क्या? कोई भी डाउट है आप चार्ट बॉक्स में डालो. I am going to just give you the clarity. If you have a doubt, if you know the answer, you don't know the answer, कुछ फर्क नहीं पड़ता. But it should not have a wrong perception in the mind. That wrong perception can deviate you like anything. So my dear students, please follow this lesson. So this is a very important slide. You please click it and take a screenshot of. Everybody just quick 3, 2, 1. Click it. Visible to everybody. Click it. अरे कम से कम thumbs up डालो यार. Okay, Shahid. Okay, so let us move ahead. Now let us talk about the physical state of the system. You say physical state of the system, it could be a solid state or a liquid state or a gas state. Yeah, Shahid. So it could be any state, but in thermodynamics, along with that, these solid and the liquid and the gas states, we have homogeneous and heterogeneous systems. So homogeneous is a system without surfaces separating the different properties of the system. That is, a system as only one state throughout is called the homogeneous system. What is that? You take a gas in a container, it is a homogeneous system. The gas container can have the mixture of nitrogen and hydrogen or oxygen. So you can't differentiate where is nitrogen, where is hydrogen, where is oxygen. So it is mixed uniformly. That is what is called as a homogeneous system. Right? Moving ahead. What is the heterogeneous system? You take a beaker and add water and little bit of oil in that. So both are liquids, but oil and water are separated by a boundary there. So that is called heterogeneous system. In a system within which there is a surface separating the different properties of the system. Okay, that is called heterogeneous system. You take a water, put an ice cube in it, so ice float on the water. So there is a two different systems, states you can see. That is a heterogeneous system. Okay, right. Real Gen Z. So you tell me how to be a real Gen Z in the class. So be like a pro, solve the question like a pro, you can be a real Gen Z. So I am more comfortable to call you by name, my dear student. So the phase, what is the meaning of a phase? Phase is different and the state is different. Phase is a set of homogeneous parts of a heterogeneous system with identical physical and chemical properties and separated from other parts through visible surface. You can see this is your beaker, in that you have water, okay, you have water, and you have coconut oil, this is oil, and you can see there is a different layer that makes the separation between the water and the layer, that is called phase junction. Enough? Right. So this is a heterogeneous system, and you take water and you add some alcohol, that is a homogeneous system. It is going to be a solution, as you know it pretty well, right? And talking about here any change in the parameter. So what is a thermodynamic process? That is, you have to know it. Thermodynamics process hota hai kya? So here it is clearly mentioned by virtue of definition. मैं आसानी भाषा में बोलना चाहता हूँ. अगर एक सिस्टम है, so but the question is that, sir, what kind of that phase? That phase is an interface, bachcho. Phase is an interface. Okay, so this is a matter and this is a matter. You are said to be a liquid state, this is also a liquid state, but there is a distinct layer that separates these two, and that is called a phase. Okay, you understand? Clear? That is called, this is one liquid and this is called heterogeneous phase. It is called heterogeneous phase. And if it is a homogeneous phase, all will be together. Okay, and you can say the same way, you take the water, if this is the water, and put ice in it. Ice is going to be, so it is a solid and it is a liquid. There is a distinct separating between these two, is called as a phase separating. Visible boundaries appearing exactly. So if you mix it, so it will be mixed or not? No, it will not be mixed. Okay, it will be agitated, you just rest it, it will get separated. Very good. That kind of interaction makes the class so lively. So live class means a teacher is energetically dancing, is cannot be a live class minded, and I really appreciating those students who are actually asking reasonable questions when the class is going on. The question is related to the current context. I really appreciate it. Thank you, Shahid. Thank you, Shahid. Okay, FF option आपका शुभ नाम क्या बेटा? So I want to know, because option, calling the student with a name option, हमको भी बुरा लग रहे हैं. Okay, just tell your name so that I can call you with your name. Okay, Shahid. Okay, fine. Gen Z, let us go ahead with this a thermodynamic process. Okay, a process. Hey Devansh, very good, very nice question. Okay, my dear students, अगर ये थर्मोडायनामिक सिस्टम एक स्टेट से और एक दूसरा स्टेट को बदल रहे हैं ना, जो ऑपरेशन बोलते हैं thermodynamic process. If a system changes from one state to another state, the operation is called as a thermodynamic process. मान के चलो, here H2O is going to be a liquid, H2O is going to be a liquid here, ice, H2O is a solid which is ice, and it is going to be converted into H2O which is a liquid, it is a water. And during this process, during this process, some amount of ice, some amount of heat is absorbed ताकि ice liquid बनेगा. Okay, and this process is called as a thermodynamic operation. Let us discuss about the details about the various types of thermodynamic process. Hi Nandini. Yes, in this thermodynamic process you can see, so any change in the parameter of the system, कौन सा parameter होता है बेटा? State function. चाहे इसको प्रेशर भी बदल सकते हैं, वॉल्यूम भी बदल सकते हैं, टेम्परेचर भी बदल सकते हैं. So that process is called as a thermodynamic process. Nandini, yeah, it is thermodynamics ka major focusing here only. So any change in the parameter in the system called thermodynamic process. ये जो प्रोसेस में मेजर टाइप्स ऑफ थर्मोडायनेमिक प्रोसेस है हमारा पास, एडियाबैटिक प्रोसेस, ओके, आइसोचोरिक प्रोसेस, आइसोबारिक प्रोसेस, isothermal process. There are major types, many types are there, उसमें major यही होता है. Okay, so adiabatic process. In this adiabatic process, the process with no heat transfer into the system or out of the system. So system का जो heat है, that is constant. Q is called heat. So dq is going to be 0 for this adiabatic process. So adiabatic process कैसे आप ऑपरेट कर सकते हैं? एक thermally insulated system में ऑपरेट करना जरूरी है बेटा. So when you will start 12th syllabus solutions chapter, maybe in the next week I can start it. So what are the topics you want? Please let me know by charting so that I can schedule a class for you. Who is going to give this offer to you? A bumper offer. Any student who are online, any topic you want me to explain, as per your doubts, as per your requirement, you just mention in the chat box. Definitely a class will be scheduled to you. Okay, so everybody can attend that. Okay, that's good. एक बार like मारो सब, एक बार like मारो. Solutions you wanted. Temperature in adiabatic process. If you see the process, if the heat, total energy of the system is going to be constant. Okay, during that process, if the heat is released, temperature inside the system is going to be released. Okay, is increased. So temperature is a measurement scale here. First of all, Devansh, you just understand temperature is a measurement scale. Heat is the quantity. Okay, so how much heat is increased or decreased is measured by using a temperature scale. Are you getting or not? Depends upon adiabatic process. It all depends on temperature can increase or decrease. We can measure by using bomb calorimeter for that. Okay? So there are so many confusions with the students. I am really happy to clarify your doubts. Okay, thank you very much. So isochoric process. Isochoric process, a process with no change in the volume, in which the case of the system does work, has no work. That is what is called as the isochoric process. In this isochoric process, dV is equal to 0, change in the volume is 0. Okay, when the volume is 0, work is also 0. Okay, that we'll discuss it. And isobaric process. Isobaric process, a process has no change in the pressure, so that I can say it is going to be dP is equal to 0. How it become a pressure is 0. Most of the natural processes are isobaric process. Okay, isochoric. Okay, so this is a freely moving piston, and gas is included, ideal gas is enclosed. Okay, now if you heat it, the piston is going to be raised. The piston is going to be raised. Okay, so that it is going to maintain the pressure constant, piston is raised. So it is called as a DP, isobaric process. Now what happened here? If you lock these things here, so piston is not moved. So what happened? The volume is constant. If you heat, अंदर का pressure बढ़ जाता. Are you getting or not? Isotonic होगा. लाल वाला जो है ना isotonic होता. Are you getting or not? Clear? You understand the variation between adiabatic, isotonic, isobaric. Gas cylinder, yes it is, gas cylinder. Okay, now let us talk about the other one. It is going to be isothermal process. Here the temperature is maintained constant, dt is equal to 0. Now Devansh, how you are making this temperature constant? You just heat it. When you are kept here, you just keep in the thermal bath, so that what happen, it can exchange the heat from system to surrounding, ताकि इसका temperature हमेशा constant रहता. You understand? Nandini, Shahid, I think Devanshu, you understand that the major difference between adiabatic, isolated system में होगा. Okay, heat बाहर नहीं जाएगा, heat अंदर नहीं आएगा. So temperature may increase or decrease depending upon the process that is taking place in the system. That is an adiabatic process, and it is more or first one and the last one is going to be looking confused. Okay, that's very good. इसमें क्या होगा? The process can exchange the heat from the surroundings. Okay, I mean to say, let us take a system in that a burning process takes place. So during burning process, heat is released. So if you allow the system to exchange the heat with the surroundings, however the process is taking place, the system temperature maintained constant, that is a isothermal process, dt is equal to 0. So it is thermally isolated, this is called thermally isolated. And thermally not isolated. It is thermally not isolated. Yeah, thank you very much. So students fear about thermodynamics not due to your inability, rather due to some kind of confusions. So these confusions are directing you in a wrong way when you solve the questions. Now this is the crystal clear picture that can make you to do. है ना बेटा? Thank you very much. Thank you very much, Nandini. You can use these thermodynamic principles in the solutions as well. I request you, suggest you to stay back so that some terminologies and some parameters we are going to discuss, that same thing you are going to use in the solutions as well. Okay, stay back if you want. Okay, thank you very much. And Devanshu, Nandini, come on. Here I just want to say thermodynamic process. And it is a clear picture about thermodynamic process. Everybody take a screenshot of this. 3, 2, 1, click. Now अगले slide को देना है. इसका भी screenshot एक बार मारना. Okay, dear children, here it is thermodynamic process, ताकि इसका isothermal होगा. T is constant, temperature is constant. Okay, and isobaric होगा, pressure is constant. And isotonic होगा, volume is constant. Adiabatic होगा, heat is constant. See, everything is available in front of you. Nandini, right? And here, no heat exchange between the system and surroundings. That is a speciality of adiabatic process. And you see, the process in which the system returns to its original state, offering a series of successive transformations, is called a cyclic process. and thermodynamic cycle. Let us say A gives rise to B, and B gives rise to C, and C gives rise to D, and D gives rise to A. इसमें what is the speciality? A system undergoes n number of changes and reaches to its initial state. So, change in internal energy is going to be 0 for this. Yeah, heat capacities in adiabatic is 0. It all depends on adiabatic process, special discussion chalta. Carnot cycle, Shahid, Carnot cycle we don't discuss in chemistry, mind it. That is, so students require here guidelines. So as Shahid says, Carnot cycle. So Carnot cycle we just initiate and leave it, and Carnot cycle is not required for chemistry, and Carnot cycle is used in physics, and Carnot cycle के हिसाब से एक क्वेश्चन भी पूछा नहीं फिलहाल. Last 15 years we just discuss in the chemistry NEET examination paper Carnot cycle, no question has been asked. So if you learn it, it is good for you, maybe it is useful in the physics, but it has 0 weightage for your chemistry. Okay, beta? So let us take the chemical aspect of this thermodynamic properties. Okay, talking about reversible and irreversible. Okay, reversible and irreversible. Very good things are there. Thermodynamic properties itself gives you a lot of importance. Why interfere Carnot in chemistry here? That's why we don't interfere Carnot in chemistry here, Devanshu. Just Carnot is left it. Okay, we are not interfering here. Talking about a reversible process. Okay, now you see here, this is a gas enclosed in ideal gas enclosed in a cylinder with a movable piston. Okay, and this gas has a pressure of the gas. Okay, and we have the pressure external. मान के चलो ये एटमॉस्फेरिक प्रेशर होगा. हाय फ्रेंड्स, DKG, या DKG. नाउ मान के चलो pressure of ATM and the pressure of the gas. So if the pressure of the gas is greater than atmospheric pressure, क्या होगा? Expansion takes place. When this piston is moving in this way, ताकि इसका pressure of atmosphere is equal to pressure of the gas. ये दोनों बराबर आने तक है, and this is going to be this called expansion. है ना बेटा? And here pressure of the gas is equal to pressure of ATM. So this is what is called as initial state, and this is what is called as a final state. So the process that is taking place from the initial state to the final state in a single shot, single step, है ना? So this process is irreversible. Mind it, this process is called irreversible, and unless somebody push from here, the piston do not come down, right? So the process that takes place in a single step, and it is called as an irreversible process. So there are two main types of thermodynamic process: reversible process and irreversible process. है ना? Follow. Once your fundamental levels are so strong, you can do the best. है ना? And the process in which the both system and its okay, let us talk about this. A process in which the system and its surroundings cannot be simultaneously written into the initial state after the process has been completed is called irreversible. It takes place in a single step, and you can just imagine and you can practice it. Irreversible process. So any doubt as of the initial irreversible process is concerned? Okay, let us do some more things here. Okay, the same thing I just want to take here, reversible process, and here this is a gas, ideal gas, okay, and the piston is placed here, okay, and this is the gas, pressure of the gas. Now you just want to put some kind of sand on it. This is a sand granules are placed here. Okay. So what happened? The pressure of the gas, this is the external pressure, and the pressure of the gas is nearly same as external pressure. Nearly same as external pressure. Sahid, yeah. Now if you want to remove this, one granule, the small change in the volume you can see, and remove one more granule, practically removing a granule one by one, what happened, you know? Finally, it takes place in several multiple steps, and it is going to be converted from the initial state to the final state. How many steps it is taking place? It was in a single step. It is called as irreversible, and it is takes place in the multiple steps. This process is what is called as a reversible process. Bachcho, is very important, and the process in which both the system and its surroundings can be simultaneously returned to their initial state after the process has been completed is called a reversible process. You know, in this reversible process so many, yeah, English में भी हम explain कर सकता हूँ, एक बार like मारो बेटा. And ये जो process है ना, initial जो step है, so initial step से final steps बदलने के वक्त में एक ही step में होता है. ओके, सिंगल शॉट में होना है. जैसे जो प्रोसेस है इरिवर्सिबल बोलना है, लेकिन एक प्रोसेस में इनिशियल स्टेप से फाइनल स्टेट से, इनिशियल स्टेट से फाइनल स्टेट जाना का मल्टीपल स्टेप इस्तेमाल करना. ओके, सो ताकि ये प्रोसेस रिवर्सिबल होगा बेटा. ये रिवर्सिबल प्रोसेस में मैक्सिमम वर्क डन एक्सट्रैक्ट कर सकते. वर्क डन is going to be maximum, ज़्यादा से ज़्यादा वर्क डन निकाल सकते हैं. Now irreversible लिखा हो ना, it is reversible का. So work done is not maximum, here it is work done is maximum. And ये जो process है ना, you can experience it, you can imagine and you can do it. Okay, ये जैसे process है ना, and it is hard to achieve it. And you can see the equilibrium सिर्फ initial state में final state में दिखाई जाएगा. Can a reversible process exist naturally? Yes, of course. Reversible process exists naturally. Agree? Yes, it is. Okay. And this is the process. Initial state से final state जाने के लिए हर step में equilibrium आप observe कर सकते हैं. हर स्टेप में, एवरी स्टेप यू कैन एक्सपीरियंस इक्विलिब्रियम बेटा. ओके, सो मल्टीपल एन नंबर ऑफ इन्फिनिटेसिमल स्मॉल स्टेप्स, थर्मोडायनेमिक्स में ये टर्म इंपॉर्टेंट है. इन्फिनिटेसिमल स्मॉल स्टेप. एनी एग्जांपल्स? यस, दैट इज द सेम एग्जांपल. यू कैन टेक ए गैस. अगर ये गैस एक कंटेनर, ये पिस्टन डाल के कंटेनर में, अगर मान के चलो प्रेशर ऑफ द गैस इज ग्रेटर देन एक्सटर्नल प्रेशर होना, तो पिस्टन ऊपर आने का, सो दिस इज इनिशियल स्टेज एंड दिस इज द फाइनल स्टेज. सो दिस इज इरिवर्सिबल. एंड यू आर आस्किंग मी एग्जांपल, imaginary example, you can do it even, but it takes a lot of time. Okay, the same you can put some sand on it. Okay, थोड़ा मिट्टी डाल के थोड़ा सा एक एक ग्रान्यूल्स निकाल सकते हैं. सो कितना दिन, ओके, यू कैन जस्ट रिमूव इट, सो दैट आहिस्ता आहिस्ता धीरे से पिस्टन ऊपर आने का कोशिश करते जब तक पूरा मिट्टी खत्म होने तक. सो दैट दिस इज कॉल्ड फाइनल स्टेप्स. समझ में आ रहे क्या? नेचुरल रिवर्सिबल प्रोसेस. So many natural reversible processes are there. Photosynthesis and growing plant is a natural reversible process. Okay, so you can see so many examples for that. Okay, and we'll discuss about this in the PV work done. So this is about the reversible and irreversible. Are you getting or not? Clear? Fine. So today's class I am really enjoying because the students are interactive here, and Shahid and Devanshu and DKG Mr. Hello. Let us move ahead. Let us talk about the PV work done and the main process in the chemical thermodynamics. two types of chemical thermodynamics processes are there. Isobaric process where pressure and temperature is constant, and isothermal process, isothermal process, isobaric isothermal, isothermic isothermal. So two variables constant रख के ये process आगे बढ़ना है. So PT constant होगा तो isobaric isothermal होगा, and isothermic isothermal VT constant होता है बेटा. So what is V? Volume constant. T is the temperature constant. So all chemical reaction takes place under these conditions. So जो भी chemical reactions आप lab में test tube में लेके करते हैं ना, this follows these two parameters. Okay, so आगे बढ़ना थोड़ा सा, and let us talk about the derivative quantities dependent on the parameters of the system, of the state, and measurable by the direct methods. So जो property है आप direct method इस्तेमाल करके आप calculate कर सकते हैं ना. So these are process functions and state functions. जो process function है ना, process का direction में depend करता है बेटा. That is what is called as a path function or path variable. Okay, and state function जो initial state and final state में depend करता है, that is called the state function. So state function, internal energy, enthalpy, entropy, Gibbs free energy. We are going to study these, and process function or the path function. Process function or a path function are the heat and work. And actually heat is generally we use a Q, and work we use a small w. Okay, so path functions or the process functions we say by using small letters, and the state functions we say by using a capital letters. Okay, students, heat and work depend on the process. Exactly. So I want to say the heat and work. Let us talk about the work. So I want to convert ice. I want to say H2O is a solid and H2O is converted into liquid. Okay, it is water. So this is the initial state बच्चों. This is initial and this is the final. You see H2O solid initial state में इसका internal energy अलग है, इसका internal energy H2O water का internal energy अलग है. This internal energy depends on initial state and final state. Are you getting or not? It is a variable. Now you just talk about the work. You can say work based on this process. This is a thermodynamic operation. How do you do this conversion? You take this ice, keep it in the bowl, leave it alone on the table. This is work. The work takes place, the process takes place, work is done. है ना? Or otherwise take that vessel and you heat it, and this is another type of process. That's a different process. Or otherwise take that ice and hammer it. It is going to be converted. Process यही है, लेकिन work अलग तरीके कर रहे हैं. So work is ये path function और process. अगर process बदलेंगे तो path बदलेंगे, path का parameter भी बदलेंगे. Are you getting or not? You understand the beautiful explanation about the heat and the work and the state function or path function. Are you getting or not? Shahid and DKG, right? Hope you understand. Wonderful. So moving ahead, here PV work, pressure volume work. Thank you. So pressure volume work. So take a vessel here, consider a cylinder fitted with a gas. Yeah, it is a cylinder fitted with a gas and it is a piston and it is moving ahead. As I said, it is a d distance is moved. And this means the volume of the cylinder is going to be L minus x. So this is the x is changed, and it is going to be simply I just want to say here PV work is given as this is the change in the volume, external pressure P external is given, okay, work done is given as minus P external and delta V. That's it. Chemistry में इतना काफ़ी है. If you apply mathematics in it, if you apply anything in it, you are going to see a lot of hell here. Now here work can be a positive if this work is done on the system. Work can be negative if the system खुद काम कर रहे हैं तो. If the work is done on the system, the magnitude of the work is a positive quantity. If the work is done by the system, this is going to be work is negative. And physics में उल्टा पुल्टा होता है, but according to the chemistry IUPAC, work is negative for expansion and work is positive for the compression. If the work is done on the system, it is going to be work positive. If it is work done by the system, work negative. Now you can see it is a thermally isolated. You can see Q is, when this piston is moving in this way, work is doing in this way and heat is entering in this way. Okay, it is isothermal irreversible process के लिए ये वाला W is equal to minus P external delta V इस्तेमाल करो. Yes, that's good, clear. And delta V क्या होगा बेटा? V2 minus V1. ये जो वॉल्यूम है ना, okay, it is V1 and it is going to be V2 and this is going to be delta V. Are you getting or not? Simple. Make the things simple. Make the things simple. Are you getting or not? Clear? Okay, Shahid. Now we can see sign conversions is very important. According to the latest sign conventions, it given by International Union Pure Applied Chemistry. Chemistry में ये governance का हिसाब से जानना पड़ता है बेटा. Okay, it is clear. Work done is taken negative if it is done by the system, since energy of the system is decreased. Example, expansion of gas. Expansion of gas. ठीक है? Are you getting or not? And if work is taken as a positive, here it was a negative. Okay, so it is taken as a positive, and if the work is done on the system, okay, work done by the system, work done on the system, and W is equal to minus P delta V, and it is a isothermal irreversible process. Irreversible process, reversible process है ना, तो क्या फर्क पड़ता है? थोड़ा छोटा सा and small steps are going to be integrated to get this logarithmic equation. Now we can see the question, find the work done in each case. Find the work done in each case. So when 1 mole of an ideal gas in 10 liter container at 1 atm is allowed to enter in the evacuated bulb to capacity of 100 liters. Are evacuated bulb? Okay, so P external 0 hoga na, so work done be 0 hoga, bas. Now when 1 mole of gases expands from 1 liter to 5 liter against a constant atmospheric pressure. And my dear students, these are the NEET level questions. First of all, you should be very confident in the solving questions. Okay, so let the questions are going to be too complicated. First, let us start with the basic level questions, and let us talk the one. So it is W is equal to minus P delta V, and P external is equal to 0. If this P external is going to 0, W is going to be 0. Bas, itna logic hai, right? You all understood this? You all understood this? Fantastic. Shahid, DKG and Devanshu, come on. Want to have a discussion with you. Now, दूसरा का क्या होगा? 1 mole of a gas expands 1 liter to 5 liters. Delta V क्या होगा? You can see W is equal to minus P delta V. So, external pressure is going to be 1 mole of the gas, and at constant atmospheric pressure 1 hoga. So that 1 is taken and 5 minus 1 is equal to minus 4 liter atmosphere. Do you know 1 liter atmosphere conversion जो है 101.3 joules होगा. This is a super important conversion. So make it in the 4 liter. So work done is equal to minus 4 into 101.3 joules. You have to convert into the joules as well. Understand? Clear? Any doubt? That's good. Fantastic. Fantastic. Now let us do some more things. Question. One more question. I want to hear from you what can be the answer for this question. Here, find the work done when 18 milliliter water is getting vaporized at 373 Kelvin in an open vessel. Assume that ideal behavior of water vapor. Conversion is important. Hai? Ha, conversion काफी important. Very important, you can't skip it. Very important. I want to know who can answer this. Dear children, here it is given water is evaporating. So when the water is evaporating from the PV is equal to nRT. As this is asked to use the ideal behavior, so that given condition PV is equal to nRT use करने के eligibility मिला. So that PV is equal to 1 into 0.0821 into 373. Okay, so 1 mole. So here it is 18 milliliters. 18 milliliters means 18 grams. 18 grams means 1 mole of water. So how do you say 18 milliliters is equal to 18 grams? It is the density of water is 1. It is a natural fact. है ना? That's good. Those students online, please click the button like button so that I can see the number. Okay, my dear students, here on doing so PV is going to be 30 liter बन गया अभी 30 liter बन गया. Now volume is going to be 30 liter. W is equal to minus PW. So volume in liter and temperature in Kelvin लेना पड़ता, and it is going to be P is equal to 1 atm at STP and W is equal to minus P delta V. So minus 1 atm to 30 minus volume of the gas. So minus 1 into 30, so 30 liter atmosphere बन गया. So 30 liter atmosphere means the work done is going to be minus 30 into 101.3 joules. That is your answer. Fine, Shahid. And this is a simple question, and you can have very good things. You can have a very good things, slight conversions I just want to give you. Okay, heat. What is the meaning of heat? Heat is defined as the amount of energy which flows between the system and surroundings due to a thermodynamic operation is called as a heat. Okay, and heat is always flows from the hotter body to colder body. So we don't need to just do any other work. You want to do it in the reverse way. Okay, you need to do a external work. एयर कंडीशन में वो इससे होता एंड रेफ्रिजरेटर में ऐसे होना चाहिए. एंड हियर इफ दिस इज द सिस्टम, ओके, इफ हीट इज गोइंग इन, Q इज गोइंग टू बी टेकन एज अ पॉजिटिव क्वांटिटी. सिस्टम को फायदा हो रहा है ना. एंड अगर हीट बाहर निकल रहा है ना, Q नेगेटिव होगा बेटा. ओके, द सिस्टम, if the heat work is doing by the system, W is going to be the negative. You can say it is a work done by the system. Okay, and work done on the system, okay, you can say on the system, W is going to be positive. That is very, very, very important. So it is all about the system to surrounding and surrounding to system, and this conversion is very, very important. Okay, and also you can say difference between heat and work, difference between the heat and work, and you will be having what is heat, you know, what is work, you know, how thermodynamically the difference between the heat and work. Okay, when a gas is supplied some heat, its molecules move faster according to kinetic theory of gases. When it is moving faster like this, okay, and with a greater randomness in different directions. But when the work is done on the same system, gas molecules are compressed and move initially in the direction of force as they got condensed. है ना बेटा? So the heat is a random from the energy while his work is organized in the energy way. Okay, work is organized, heat is randomized. हिंदी मीडियम से इंग्लिश मीडियम आए, ओके गुरु बाबा आ सकते हैं, आप अंग्रेजी सीखो, हिंदी में सीखना है. Okay, next let us see here that is the difference internal energy and the first law of thermodynamics. What is internal energy? Internal energy है, so the sum of all types of energies in the system is called internal energy. Okay, you can't establish the absolute value of internal energy. That difference in the internal energy you can calculate it. The first law of thermodynamics is it is based on experience that energy can neither be created nor be destroyed. It is called as the first law of energy, but it can be changed from one state to another state. Okay, so energy you can't create it, energy you can't destroy it, but energy you can convert from one state to another state. And if some quantity of energy is disappeared, same quantity of another energy has to appear. If some quantity of energy is disappeared, or at least some same quantity of work should be done, that is what is called as a first law of thermodynamics. So internal energy is the sum of all types of energies is called as a internal energy. And this internal energy is absolute values you can't calculate it, rather you can calculate the difference in the absolute energies. So that first law of thermodynamics is rated as here. Let us say this is a system, it is internal energy U1. मान के चलो इसका थोड़ा सा हीट दिया गया, साइमल्टेनियसली इसका थोड़ा सा वर्क भी किया, ताकि इसका इंटरनल एनर्जी U2 बदल दिया. Okay, we are resetting our past. Please don't chart anything other than academics here. So internal energy U2 कितना होगा बेटा? U2 is equal to U1, इसका कुछ दिया Q and इसका कुछ दिया W, and I just want to say U2 minus U1 is equal to Q plus W. U2 minus U1, delta U is equal to U2 minus U1. U is called internal energy, है ना? So that is called delta U is equal to Q plus W. So this is called mathematical form of the first law of thermodynamics. Shahid, DKG and Devanshu, hope you understood this session. And today we started with what is the importance of thermodynamics and basic terminologies of the thermodynamics and the uses of the thermodynamics, and I have taken the clarity of various thermodynamic properties, and eventually we discussed about the first law of thermodynamics. And this is the session 1, or 2 more sessions are there. I want to conduct it for the applications of first law of thermodynamics and second law of thermodynamics and Gibbs free energy, so that 3 more sessions I just want to conduct it. So as of now, today we completed, and we will discuss some more stuff in the upcoming session. So I strongly requesting my dear students, please like this session and share with your friends. इन लोगों के भी फायदा होना चाहिए. So that please subscribe to Infinity Learn NEET YouTube channel. So okay, so please subscribe to the channel so that we will be giving you all updates about when the class is going to be. Again, we'll meet in the next session with more stuff. Okay, thank you very much. Signing off, Suresh, Faculty of Chemistry from Infinity Learn NEET YouTube studio. Thank you very much. Bye bye.